Okay, so let's solve a couple of different problems involving parallel circuits. The first one states, what is the total resistance of a parallel circuit that has 10 100 ohm loads? So we learned earlier that if all the resistor or all the loads are the same, we could apply this very simple formula here. The resistor value divided by however many there are. So in this case, we've got 100 load resistors divided by, there are 10 of them, and that division becomes 10 ohms. So very straightforward. Um, this is an easy question to answer because all the resistors are the same value. You could use this formula. So it is very straightforward. Let's take the next question. And we have a parallel circuit operates on 120 volts. There are two loads in the circuit, each of them 200 ohms. What is the total amperage of this circuit? So let's draw this circuit. Very simple. It's got two loads in it, each of them 200 ohms. And we're asked to find the total amperage. We're asked to find IT, which is right here. And the amperage leaving the circuit will be the same as the amperage returning from the circuit. So we notice that the resistors are the same, so that we could use this total resistor formula, and that is the resistor value divided by the quantity of resistors. The resistor value is 200 ohms and divided by 2, and the total resistance is 100 ohms. Well, it's a 120 volt circuit, so we have all that we need to solve for amperage. We have the voltage and we have the total resistance, and all we need to do is to divide voltage by resistance to get IT. If that doesn't make sense, just draw your circle. E equals I times R, and then plug in your values. E is 120 volts. I is what we're solving for, and total resistance is 100 ohms. And you can see that 120 divided by 100 is going to equal your total amperage. So your total amperage will be 120 volts divided by 100 ohms, and that is 1.2 amps. So 1.2 amps is here, leaving the power source, and 1.2 amps returns. Let's take the next question. What is the amperage of one of the branches of the circuit above? So let's draw real quickly the circuit above. That was a resistor here and one resistor here, and we had 200 ohms each resistor and a 120 volt source, and 1.2 amps was the total amperage. The question here says, what is the amperage of one of the branches? Well, if we know in a parallel circuit that the voltages are the same across each load, that means that there's 120 volts between here and here. And we know already that the resistance is 200 ohms. So again, we have the elements that we need to solve for the amperage of this branch. We have the voltage, we have the resistance value, and all you're looking for is I, or amperage. So let's plug it into Ohm's law. Just throw in these values. We have 120 volts, and we have the resistance value of 200 ohms. And it's asking for the amperage in just that one branch. So we divide 120 divided by 200, and we get 0.6 amps. So 0.6 amps is coming down this branch here. Well, that kind of makes sense, because if you notice, if 0.6 comes down this branch and you start with 1.2, you know that 0.6 is going this way. So the combination, the sum of these two currents equal 1.2. The same you could see coming back. If 1.6 comes back and meets up with this current here, 0.6 plus 0.6 is 1.2 amps. So you could see that they combined to reach the total amperage. So let's take a next one. What is the total wattage consumed in the circuit above? Well, let's draw that circuit again very quickly. 100 volts. You have your two resistors. Each worth 200 ohms. And we determined that the total amperage was 1.2 amps. 1.2 amps. So using our power formula, which is the total power is equal to the total amperage times the total voltage, we have all the elements we need to solve for total wattage. So we could put P up here. Amperage is 1.2 amps, and the total voltage is 120 volts. So P is equal to 1.2 amps times 120 volts, and that product is equal to 144 watts. So that's a little explanation on how to use Ohm's law and the power law and relate them to the properties and to the rules of a parallel circuit.